quick. Graph y equals 3 halves times the quantity of x plus 4 cubed by hand, two different ways. This is part of the Family of Functions series. You will need graph paper or download this PDF, print it. Press pause as needed anytime during this video. First, decide what the parent function is and its shape. This is the cubic function, and its shape is this shape right here. So keep that in your back of your mind as we're doing this. Identify the parameters, which are values in the expression that affect the graph. There are two parameters for this function. How do they affect the graph? Well, the plus 4 is inside the parentheses or inside the function, and that shifts each value to the left 4 units. The 3 halves multiplies each value, each y value. So what should we consider first? Well, we suggest plotting the point of inflection first, which is this point right here, where the curve changes concavity from a frown to a smile. It's normally at the origin. So the curve changes from concave down to concave up. That's called a point of inflection. Normally at the origin. And so since each value is shifted to the left 4, that'll become negative 4. And we're multiplying each y by 3 halves. That'll keep it at 0. So the point of inflection will be at negative 4, 0. From this point, we'll do the cubic dance, but it will be affected by multiplying by 3 halves. So instead of right 1, up 1, like we normally would, it's going to be right 1, up 3 halves, because we have to multiply 3 halves times 1. Instead of right 2, up 8, it's going to be right 2, up 12. 3 halves times 8 is 24 halves, or 12. Instead of left 1, down 1, it'll be left 1, down 1.5. And instead of left 2, down 8, it'll be left 2, down 12. Negative 3 halves times 8 is negative 12. Connect the points to look like a cubic-looking curve. The point of inflection, negative 4, 0 is where it goes from concave down to concave up, and compared to the parent function. Second way, using a table. These are the 5 values we normally plot for the cubic graph, y equals x cubed. The plus 4 is inside the parentheses, so it affects the x values. We need to subtract 4 from each x value because it shifts to the left 4. So we need to subtract 4 to get to the left. So 2 minus 4 will be negative 2. 1 minus 4, negative 3. We ask you to go ahead and finish those. Pause to do so and resume when you're ready. So 0 minus 4, negative 1 minus 4, negative 2 minus 4. Those are our x coordinates. The 3 halves affects the y values. We need to multiply each y value by 3 halves. So starting with 8, 8 times 3 halves would be 24 halves, which is 12. So we'll plot negative 2, 12. Again, we ask you to finish the table, plot the points, and finish the curve. Press pause to do so. Resume when you're ready. One times 3 halves is 3 halves, so negative 3 up 1.5. 0 times 3 halves is still 0, so negative 4, 0 is our x-intercept. Negative 1 times 3 halves is negative 3 halves, so negative 5 down 1.5. And negative 8 times 3 halves is negative 24 halves, which is negative 12. So negative 6, negative 12. Connect the points to look like a cubic curve compared to the parent function. Now you try one. Graph y equals 2 times the quantity of x minus 5 cubed. Use either method or both for the practice. Press pause to do this and resume when you're finished to check your answer. And here's your answer in green along with the table so that you can check your ordered pairs.